Welcome viewers. In this video we are going to do load applications into the robot structural model which we have prepared already for design of warehouse structures. So in this we are going to apply dead load, impose load, snow load and finally the wind load. Remaining crane load will be applicable, we are going to apply on the next video. Let me look into that load applications methods and the robot structural analysis from the Excel calculation which we have prepared. This is a model which we have developed in our first stage. So in this model we are going to apply the various loads which we have calculated, and this on the screen you can see that Excel calculation which we have prepared for the loads and load combinations. So far in the last video we have seen that load combinations. So these are the various individual load we need to apply on this. So in the model we need to create these loads. Go to the model, loads, load type. So we are adding those load here. So first one is dead load, add. Second one is impose load on the roof, which is category H. So similarly we need to add all the load cases. So these are the various load types which we have added. The dead load is self weight of the structure and the panel weight. Second one is impose load, roof category as a H. Third one is a crane load, which is also imposed load, which is a category as a E. Fourth one is a uniform snow load throughout the roof. Here that altitude is 50 meter for us, so we are considering H is less than 1000 meter above sea level. So this is a snow load applied uniform towards all the roof. And the fifth category we are going to apply only the left side of the roof. The sixth load type is we are going to apply on the right side. The seventh one is a wind acting in the longitudinal directions of the building, which is parallel to Y and perpendicular to the longitudinal side in the left side. And the load case 8 is a wind acting in these directions, that is from the right side shorter span having a middle wind post. And the ninth load type is a wind acting from right side of the longitudinal direction of the building, which is acting in y directions minus y. And the 10 is a external wind acting from the shorter directions, which is here in the left side. 11 is the internal pressure coefficient acting outward, which is a positive, and the 12 is a internal pressure coefficient acting inward, that is negative. So these are the 12 number of primary load type which we have added. We are going to apply all the calculated loads which is in the left hand side, that Excel calculation which we have done this load calculations for dead load, imposed load, wind load, snow load, and also the load combinations we have calculated in earlier part of this design of a warehouse video. So now we are going to apply this load, and as we see that load type we have added already. Now instead of adding these load definitions, geometry code, loads and load definitions, this will take more time in order to understand this. What we have to do is we are going to apply this all the loads by load table method. So for that, go to loads, click load table. So we need to select this window vertical in order to view both the model view window and the load window. So here that load case we can apply the first load, dead load. And coming to this list, what we can do is we can select all the members in the tab here. So now you can see the windows. So all the members are selected, and you can just copy and paste here, but before that it had already selected. Now it is mentioned at a part of the structure model, because we are not going to apply this cladding weight as a self-weight directly. So and this factor is 1. So now we have applied the self-weight of all the structural members. Next we are going to apply the roof loading. So for that, select this case as dead load and go to here FE uniform. Sometimes this FE uniform is not listed in the load table. For that we need to, if that is the case, we need to go to these loads and click these load definitions, and as a sample or in order to add this load list to the load type, we used to do this. So click this uniform plane, and here you can consider that minus 0.55 or any value, add here and just pick this value, so that you can able to see that downward force, vertical forces here for this cladding. So then you can close this, and now you can able to see this FE uniform in case if it is not available there. So now we can delete this sample, and for this applying this roof cladding we have selected this FE uniform, and we need to pick whichever the cladding is applicable for roofing. So select this and click this new window and select any one of the cladding and go to right click and click select similar and select by materials. Now you can see this only the cladding, roof cladding is selected, and then copy this cladding. So by default the robot will take the cladding numbers once you are selecting this. If it is not happen, you can directly copy from here and paste it here. Now this is in Z direction, and it is a minus 0.55 as we have calculated in the Excel. So this value we have applied there. As it is a downward, we are applying minus 55, and you can also click this load views in the bottom of the model window, 1, 2, 3 and this load symbols, and you can see this 0.55 is applied now. Next load we are going to apply is a cooling water pipe and the duct system. So for that 0.35 kilonewton per meter, that is 35 kg per meter we are going to apply here. So for that select this one dead load, and this would be uniform load on the beams. So here we need to select this beam. Actually we are having a separate window for the roofing, so we are assuming that this members are subjected to the cooling water pipe. So we are going to apply this cooling water pipe loads on this member, which are selected in which are showing in the blue color. I think this roof bracing should not be selected, and so after selecting this, as usual we need to select this member number for our safety, but before that it is already selected in here. So we can directly apply this minus 0.35 kilonewton meter here. So you can see here the value 0.35. So next we need to apply the wall cladding. For applying the wall cladding loadings, there are various methods we need to consider, but here what we are going to consider is we are going to apply as a point load on every columns which are supporting this cladding. Generally this cladding is to be supported with a side rail, and that side rail to be connected at the vertical column. So these vertical column used to hold the side rails at 1 meter or 1.5 meter center to center distance of each, so that side rail will hold the cladding. So here what we are going to do is we are going to calculate the entire area load and multiply it with the height and the width of each bay. Accordingly we are going to divide those into two, It means for end column half of the cladding load should be applied, and for mid column the entire, that is both the bay we are having the same span, so the one bay distance, that is 5 meter for longer span each bay, that should be applied here as a point load on the column at the center of gravity. So that's what calculated here. In the longer span we are having each 5 meter bay, and in the shorter span we are having, for this wind post we are having 2 bays only. So it means the total span of 18 meters is divided into 2. And also in other side you can see that this side, for due to the rolling shutter and for the 2 wind post divided here, we are having a spacing at 1.5 meter each, and 9 meter is the remaining one. So that's why we are calculating here for 5 meter, 9 meter and 4.5 meter. So we are multiplying this 5 meter with the 0.4 kilonewton per meter square, that is a side rail and the wall cladding weight in kilonewton per meter square, with the height of the building is a total 12.8. So you can also do that accurate weight by considering only the height up to the eave in terms of longitudinal directions of panels, and for width direction alone, for the ridge position alone, we can consider 12.8 meters. So that kind of detailed calculation is not performed now because it will take more time. So these are the end, the 12.8 and 23.04 in a 9 meter span, and 11.52 is a end column load values. So this we are going to apply on the loads. So for longitudinal end column we can consider this and this. Also in the other side we can consider this and this. So copy. So here we can consider as a dead load, uniform load, and these are the members which we have copied, and this can be minus 12.8. and this is what we have applied. And then similar like for all the other columns also we need to add it. For the end column it is 25.6. so it means wherever the column is coming here, that should be selected and applied the 25.3. even in the other side also this is applicable. So here is all the vertical cladding loads are applied. So you can see here that is 25.6 is a longitudinal mid, 11.52 is a end column, and here that shorter column is a 12.80, and here 23.04 is a short direction, that is width direction end, and middle column is a 46.08, and in this side it is 12.8 and 34.56. this is because half of the 4.5 meter and the half of the 9 meter span is going to apply here. So that is why this value is considered 34.56. and we have applied all the wall cladding loads also. So these are the loads, dead loads we have applied. Now the rolling shutter loads we need to apply. So here it is 0.15 kilonewton per meter square. So this load we are going to consider on the beam. So this weight per meter is 0.9 kilonewton. So we are going to apply for this beam. Minus 0.9. And finally there will be some moment. So that is 1.62 kilonewton. So that moment also we are going to apply here. Uniform moment. So this uniform moment will be acting in y directions due to this vertical load of the, you can see that y axis, the global y axis in this directions. So the load is going to come out with the eccentricity, so that this will be having a rotation about y axis. So we need to enter this value in my 1.62. so you can see here the moment value. So you can also give that minus value, so that exact moment can be viewed over here. So this is in y direction due to that self height of the rolling shutter. So far we have applied all the dead loads. So these floor loads we are going to apply in the floor directly, which is not applicable for this structure design. That should be look into that foundation design and the floor slab designs. So this is all about the dead load. Now next we are going to apply the imposed loads. So imposed load is as per this maintenance category H, we are going to apply on the roof. That is a second load. So this is also FE uniform. So for that we need to select this again, the roof loads. So instead of selecting and taking this cut view, we can directly copy this member and paste over here, and we can type as -1 kilonewton as a PZ, so that the vertical load, downward load is applied here for as a imposed load on roof category H. So we have applied this load also, maintenance and category loads. So remaining is this all floor areas, so that is also going to apply on the floor loads, so not in the structure model. And next we can look into that snow load. The crane load we can see later after applied all the other loads except the crane. So coming to the snow loads, there are two kind of snow loads which we are going to apply. One is full wind, full snow. Another one is half of the portion is going to apply on the roof. Again this half is going to divide in left side and right side. So let we see that. So as we know that the snow load is having uniform load, so this category we are going to apply that uniform snow on all roof. So similar we can copy the same here and apply as -0.4, which is we calculated here, and you can take the cut view here for the next load case. You can select this half of the panels and go to this load table, select the fifth load case. So here we can select from here, or the program will directly select here and show here. So this should be 50% of the snow load, so -0.2. Similar like for next snow load case, we need to select this right side roof panels, go to that sixth load case. Again here for safer side we can copy here if the program is not coming default, so but the program is coming that with the default value. So this is also -0.2, 50% we have considered. So now we can check this view. So for selecting the load 6, selecting the load case 5, it is showing the left hand side. Now it is in the right hand side. If we are going to select the fourth one, it is applied entirely. So we have applied the snow load also. Next we will go to the wind load. So this we have applied. Coming to the wind load, we already having the table. So this we already calculated during our earlier part of this design of ergo structure videos. So now you can see that windward face. So this is a first case. There are 4 cases we need to consider. So let we go to the model view, and coming here, select the wind acting along this case. So here again we are going to apply on the wall roof claddings. So we need to consider this FE uniform. So what we are going to consider here is we need to select this longitudinal left hand side panels. We can select here and cut it. Select material so that we can select only the left side wall cladding. So we can again do this copy, and you can come here we can paste it, and this is like in y directions. So as per this table you can see that the pressure is applied pressure on the face of the wall, so that it should be in towards the wall directions from the outside of the building, so that it should be in global y positive. So here this py we need to apply 0.8. so you can see from here. So actually this case the wind is acting this directions, which is showing here. So remaining all other sides it should be act like a suction. It means wind should be act from the face of the wall and towards the outside of the building. You can see here remaining value as 0.547. It is a levered. Levered is nothing but we need to select from this window. We can close this window and we can select this panel alone to edit in new window. So again we need to select this, right click, go to this, select materials, and this we can copy, and we need to apply again the 7th load case, paste here that, and this if you are looking it should be acting outward of the building as a suction. So this is also in y direction positive, so the value is 0.47. so you can see it is acting outward of the building. So we can close this. Next we need to select this side and edit in new window. Similar like same thing we need to do, like select this, copy, and 7th load case FEM uniform, and here this case it is x directions we need to apply as a suction load. So here that x positive, because this is also going to act outward of the building. So the value is 1.15. so it is a positive x 1.15. so you can see it is acting outward from building face to outside of the building. So we can close this and we can select from the other view, that is double wind post side. So here again we can select this and select material. So this we can again copy for our safer side. And here again we need to add 7. And this case if you see it is if it is in global x, so if we are going to apply in positive x, then it will be acting face of the wall, so it must be away from the wall. So we need to apply as a minus x. So here that value is same as charter direction lever. So you can see now this load is acting away to the face of the building from inner side. Next, finally, we need to apply for the roof loads. So roof loads, we no need to do the cut section at all because we already done those for snow load cases. So what for roof face of wind, it means the left hand side of the roof should have 0.94 as a magnitude. So again we can create this 7, and also the 11 right side also we can create one more load. So we know that we have calculated the snow load here. So this same member we can copy and paste over here. So that we can directly apply those. So this case we need to apply the vertical load. So we know that it is a 0.94. So we need to apply this as a 0.94 because vertical is a positive here. So this is also suction, which means it is moving outward from the building face, so it should be upward. So for the next right hand side also we can select this sixth one. So for the sixth one, these are the roof claddings we need to select, and we can copy and paste it over here. And this is also 0.94. No, this value is different, I think, from the calculation. Yeah, it is 0.6 we need to consider. So 0.6 we are considering here. So now look into this arrow mark, you can able to identify. So this side it is suction only. In the vertical directions we can see that the roof load, all the roof loads are in upward direction, it means towards the suction. So we have applied the 7th load case in all the claddings. So similarly, like the same method, we are going to apply the wind load of 8th case, which is x directions. It is in this shorter direction. So this is applicable for all the cases. So we need to create all 6 number of load lines for 8 also, because 4 side of wall cladding and the 2 side of the roof cladding we need to create. So totally 6. So we can copy paste this all the cladding numbers and so that we can change only the magnitude and the directions, so that all the load can be applied. So by this way we need to apply all the wind load cases. I have applied all the wind load cases for external wind pressures from load case number 7 to 10. Now again we need to add for internal pressure coefficients 11 and 12. So for that what we can do is we can directly copy and paste this entire external wind pressure coefficient, so that we can copy the cladding, and instead of 9 we can change this to 11, and instead of 10 we can change this to 12. So now for the internal coefficient pressure for this external longitudinal cladding, we can find this. Here you can see these are the positive values. So positive values the maximum we need to consider, and also the negative the maximum, the minimum we can consider. So 0.-33 and 0.33 for positive we need to consider for both the cases. So what we can do is we can directly apply here for that. So if you see that y directions for internal positive means it must come from inside to outside of the outside face of the wall, so that it should be minus of y, so that it is acting from internal. So minus 0.33 we can directly apply on this. And for other side cladding, this side this should be positive, because you can see this arrow mark which is inside in the left side longitudinal side, and so here it should be positive. And for x directions, for shorter direction, it should be negative 0.33, so that it will act. And this side it should 0.33 positive, so that you can look from here. This longitudinal is acting from inward towards the face of the wall, and this side also it is acting towards the face of the wall from the inside. So what we have applied is correct. And for ceiling, we need to consider the 0.03 vertical. For both the left and right. So case number 11, that internal which is acting towards outward to the building enclosure. So this we have assigned already. Now next, the load case number 12 we need to apply. So this is directly opposite to the value which we have assigned in case number 11. So it should be 0.33 positive, so that it will move inward of the building wall cladding facing. And here also this should be minus 0.33, and this case x direction is 0.33 for this cladding, and here we need to consider minus 0.33. So here it is 0.33. And from the top view, both are minus 0.33, so that it will act downward, which means outward from the building faces. So you can see now this side it is outward, and this longitudinal left side also outward, and this side also it is going out. This arrow mark, this side it is wrongly placed. Yes, this is also outward, and even in the roof also you can see that it is acting downward. It means away from the face of the cladding. So now we have applied all the 12 load cases. So look description for more related videos and subscribe to this channel for more updates. Thank you.